So I'm running into a height issue. The mill is plenty big enough. You can see it's got probably another foot worth that I could go up. But you can see the problem here is I don't have it here. Now I could cut a hole in my ceiling, since it is only ceiling tile, which ultimately is what I guess I'm probably going to end up doing. It's either that or take it to work. I suppose I could possibly do that as well. I'm not sure yet on how to go about doing this, but I just wanted to give you guys an update on where I was at. This is the game plan so far. Right now I'm going to go through and I'm going to drill holes in this, and it's going to screw down to the lathe plate base, the lathe base. Ignore this. This is going to be lifted up much higher. And then these will be on here. This is for the ball screw. And then I'll have the x-axis going this way. Now I think I'm going to put this on a slant, but I guess that's neither here nor there right now. First things first is figuring out how to drill this. The other thing I'm thinking is, because I took away the V here, which made sure that this spindle remained straight to this bed, what I'm considering doing is, when I mount this on the block of steel, making it movable so I can adjust it ever so little bit, just in case everything isn't perfectly parallel. Because unfortunately, taking that groove out, I always knew that was going to be a risk. So we're going to have to see what happens. I upgraded these bearings to angular contact, so I put the best bearings possible in this head. This thing is still so tiny, I don't know what's going to happen, but you know, I'm going to give it the benefit of the doubt and assume, you know, it should be able to do what I need it to do. Unfortunately, I keep talking myself out of which way to go, because I feel like this way would be a little better, not having so much plate and adding so much height. But then again, these are narrowing, which I was trying to avoid doing. But in the end, I think this would be easier. What do you think? You don't know, huh? All right. Well, me and my associate here are going to discuss it. I'll get back to you. All right, here's what I'm thinking for the spindle mount. This is just scrap. I'm gonna face this completely flat, both sides. And what I'm gonna do is, this has 3 holes. I'm gonna make a 4th, so it's so they're all asymmetrical. I'm going to drill this plate out from the bottom, counterbore it, so this plate can be mounted to this spindle mount, and then I'm going to drill 4 holes to mount this plate to this chunk of steel. This steel is like 4 by 4 approximately. It's a little bigger than that, but I mean, that's the gist of it. And that should, in essence, raise the spindle up enough. Because, I mean, bear in mind, we're adding a layer of, well, 2 layers of linear bearings, and then we're adding blocks and, you know, whatnot. So I've got to raise this up, and I've got to keep it as stable as I possibly can. And I don't see a better way to do it. So the question comes in now, do I, like I said, I want to make this adjustable. So do I pivot this, put a hole in the center so I can turn this, and then, you know, have slotted holes on the outside? That way, if I need to adjust it just that little bit, I can. Or do I just skip the hole in the center, do 4 big holes, get it as close as I can, and that little bit of adjustment should be in the holes, if that makes sense. I don't know. Stay tuned. I know you've seen this before, obviously. This was part of the mill design that I was making. And I've decided to try to salvage what I can from that for the time being for the lathe project. And one of the things that I've noticed is doing this, the depth, you know, from the bottom of this plate to the top of this is going to be, well, let's say 7 inches. And that's pretty substantial when you consider having to raise up the spindle. So I'm a little concerned that doing it like this may not be advantageous, because obviously the higher I make this, I think the less stability I'm going to have. I mean, granted, the linear rails and everything that I'm doing is definitely going to be a heck of a lot more stable than it was, by far, guaranteed. But at the same time, I don't want to design myself into a corner where this is going to be, how can I explain this? I don't want to spend all the time making this to find out that I designed something with a great big flaw in it, and it's going to turn the same as it was before I did all this work. I mean, it'd be redundant and a waste of time, which, don't get me wrong, I'm used to doing that, but if I can avoid it, I'd kind of like to do that. So I'm going to do a little bit of thinking about this, about what to do about this height thing, because this really does add a lot of height. By the time you add this 1-inch plate, these linear rails, you got to make it high enough for this ball screw, you know, and then you got this 1-inch plate, these linear rails, you'll have the plate on top of here, and then the main plate where the tool is going to sit. I'm going to try to think of a way to lower this and get it as low as I can. If I can't, I can't, but I'm going to see what I can come up with. I was struggling with trying to make limit switch mounts because, you know, every X, Y, and Z axis is a bit different. And I tried to find out or figure out what they all had in common. And the one thing that all of these mounts have in common are these linear rails. So I thought to myself, if I'm going to do these limit switches, why not make it so I can attach it to, you know, something that I know is the same on all of the rails. So I went ahead and I 3D printed it to see if it would work. And as you see, it did. Basically, you have a set screw, you have the shape, and then you have the holes for the limit switch. So then I went ahead and I made it out of aluminum. Came out pretty nice. And this goes on here. It actually slides on pretty nicely. I haven't done the set screw yet for it, but the nice thing is these are adjustable and they can easily be put on all of the axes, including Z. Well, bear in mind, Z I used, these are 16 millimeter, these are 20. So I have to make a different style for the Z, but you get the point. It will work the same way. You know, you can set these where you want, tighten up the adjustment screw, and you're golden. Converting this mill to ball screws is one of the best things I've done. I'm actually extremely happy with how it came out. I've been slowly but steadily replacing all the plastic parts with steel. This right here is printed. Let me see if I can put the light on. Hang on. There we go. Now this is plastic. This is solid 3D printed plastic. So what I did was I went through and I made aluminum so I can replace this with aluminum. I redesigned all of this to make it out of aluminum. The part in here that accepts the ball screw, you can't see it. It's actually inside of there. That's plastic as well. It's basically this. Now I went through and I made it out of 4140, I think it is, steel. So slowly but surely now I'm going through and replacing all these parts with steel and aluminum. And I have to tell you the difference. Now this hole, before when I was to make a hole, it would be weird shaped. It would have marks on both sides where, you know, the backlash was. And even though, even with these cheap Chinese ball screws, there is a very slight amount of backlash, the difference is astronomical, night and day. So I'm actually really enjoying the difference in the ball screws from the Acme screws. The motors seem to work a little smoother too. So just, you know, food for thought, just letting you guys know. I'm actually very happy about this little upgrade I did. But that's it for this video this weekend. Holiday weekend. Kind of been real busy. I ended up, got an exhaust leak on my car I got to fix. I got a service engine light with an evap, I don't know, problem. Now, usually every time my service engine light comes on, it's, you know, an O2 sensor or some ridiculous thing like that. But unfortunately, the newer these cars get, the harder they are to work on. And I really don't know crap about, you know, these evap systems or whatever. Kind of thinking I'm out of my depth here. But so I got to try to work on that this weekend. So I'm going to probably be busy. But anyway, I wanted to at least get a video to you guys, show you what I was up to, what kind of crazy trouble I'm in. And, well, enjoy your weekend, guys. I'll catch you later. Have a good one. taking 2mm cuts at a time.